The Land Before Time is a glimpse into a world of old, of creatures of horror and might, a landscape of death and fire. This is a world that is unnatural in nature and not exactly one that's ever existed. Because in the creative liberties the movie took, it created hell on Earth, an environment so weird and deadly that if applied to any sense of science or logic, would fall apart immediately. This is a video on the ecosystem and ecology of the Land Before Time, from the weird unnatural placement of dinosaurs that live in it and how they would clash, the environment and how it's unnaturally deadly, and how it affects the animals and planet itself, and the true horror of the Land Before Time. Let me explain. The Land Before Time ecosystem is one that is built not in science in any conceivable way, which is entirely okay because the movie is going for this fantastical, dark, apocalyptic vibe outside of our own world, but when you analyze this movie with science, it becomes alarming. Let's just start with going over the basic problems of the Great Valley and how it conceptually doesn't work. See, an ecosystem has, in a way, a carried capacity, or a max number of animals it can support. Why? Well, basic things such as water availability, the landscape and climate, plant growth, and the type of organisms themselves shape how many can live here. That's pretty simple enough. What makes it more complicated is when the type of organism is, say, a herbivore, which is the most resource-intense animal on Earth. Specifically, large herbivores like the dinosaurs that live in the Great Valley. Why? Well, think about it. An elephant eats 330 to 660 pounds of plants per day. Now, moving to dinosaurs, we have estimates that say a triceratops would eat 110 to 220 pounds of plants, and a theropod would consume more than triple that at 440 to 880 pounds. That is simply a lot of food, and when you have dozens of these animals in a closed-off paradise like land, isolated by deserts and mountains, things get bad. The Great Valley is a place of no ecosystem expansion, where everything is bundled in one tight valley with no migration, no external food sources, and most importantly, no predators. We'll go more into the predators in a minute, but just going over the issue of how many herbivores we have is that they eat plants faster than they grow, and in return, we get a famine. Now, this movie is one that paints a hellish world where famine is already happening, but the problem is that actually this natural valley isn't where it will be really happening. Now, moving on to the predator problem, we have a big issue, or really a lack of one. There are no predators in the Great Valley, which just doesn't work. An ecosystem needs predators. They are essential to controlling herbivore population, removing the sick and weak, which just help an ecosystem's population on both sides in the long run, prevents overgrazing, and forces everything to evolve and be biodiverse. Without any of these things, an ecosystem will collapse in a great flood of herbivores that will grow and grow in an endless surplus till they eventually run out of the bliss of their Great Valley and die out in a great starvation. I actually talked about something similar in my Zootopia video, which you should definitely watch after this one. It's similar in concept, but obviously different problems, so go check it out. After this one, of course. And with that, we can move on to a bigger problem outside of the Great Valley and just present in this world itself. That is truly before time, because if it was on our timeline, it wouldn't make any fucking sense. Let me explain. This is Littlefoot. He's an Apatosaurus dinosaur from the late Jurassic period 152 million years ago. But that makes sense, he's a dinosaur, except dinosaurs did not all live at the same time. Now, I know before you say it, this is the most annoying complaint anyone makes about any dinosaur media like Jurassic Park or this movie, but I'm not really complaining, I'm simply acknowledging that the dinosaurs in this movie don't make any sense and would affect things. The biggest example of this, other than say all his friends being from not the same era, is the villain of this movie being a T-Rex, which existed 86 million years ago, which is only a small 66 million year gap to Littlefoot. Now, the problem here is all these dinosaurs can't thrive together. They consume different plant life, need different climate conditions, different literal CO2 levels. They're simply entirely different organisms of practically different planets smushed together in some hellish world of death and fire. Speaking of that, I think the more interesting thing to talk about is really the climate. But before I do that, how about you do something for me? It's very simple, I promise. Simply push that subscribe button if you like that, maybe turn on notifications. But really, it would be very nice of you. I've undermined the idea in the past and felt it silly, but apparently asking people to subscribe actually works. So if you like the video, and getting more videos since I'm trying to do the insane task of 3 videos a week, it would be great if you subscribed and just watched. Either way, back to the video. This film shows deserts, mass deadly earthquakes, a horrible drought, and all at the same time, this lush luscious, unnatural paradise in the Great Valley. This obviously represents an extremely unstable climate and ecosystem in terms of geography, but we are still ignoring just how hellish it truly is. Repetitive mega disasters like this would be completely ecosystem resetting, because earthquakes, droughts, mountains that are just permanently on fire make a world of soil without nutrition, a food chain that can never become truly stable, and stop plant growth entirely. Now this movie does show this in some way, showing dead trees and whatnot, but doesn't truly explore how nothing should exist on this planet. Let's start by breaking down the concept of the volcanic mountains of fire and lava that exist in this world and how they would affect things scientifically. We see dozens of always erupting volcanoes, massive rivers of lava, constant ash clouds in the sky, and just a city of bones everywhere you go. Great. Let's compare this to 3 scales in the real world. Normal Earth volcanism works like this. The Earth produces a large amount of lava a year that is equivalent to basically 3 mountains of lava. Now in extreme periods of Earth's history, we have more lava mountains made. Say the Iceland flood basalt would give us an equivalent of 20. Now in the real world, while dinosaurs were not killed by volcanoes, there was a massive extinction event in the Siberian Traps, which had a total of 100 volcanoes per year just over the course of a million. Now this movie gives us what I can only say is an extreme hell-like example of volcano output, where I'm estimating 200 volcano lava mountains per year, which is 70 times our normal. Now converting lava production to the amount of heat released is where the effects start to occur. Fresh basalt lava is about 1,200 Celsius or 2,192 Fahrenheit. Now with this, we then need to figure out how much heat a single cubic kilometer of lava releases as it cools. We can start with mass. Basalt rock has a density of roughly 3,000 kilograms per cubic meter, with a cubic kilometer containing 1 billion cubic meters. So in return, the mass of 1 cubic kilogram of lava is about 3 trillion kilograms. That was a lot of numbers and words. Next off, we can figure out how much heat that lava loses as it cools. We're cooling from 1,200 Celsius down to 20 Celsius, which is room temperature. That's a temperature drop of 1,180 degrees. Now basalt stores about 1,000 joules of heat per kilogram per degree, so when we multiply all of this together, 1 cubic kilometer of lava releases roughly 3.5 times 10 to the power of 18 joules of heat. That is a stupidly absurd amount of energy, but it gets worse. In our hell scenario, we estimate about 200 cubic kilometers of lava erupting every year. So what do we do now? Well, we multiply again, and we get 7.1 times 10 to the power of 20 joules of heat in the world every year. Now with all this in mind, the actual effect of the direct heat from these horrible pits of lava and death aren't really that crazy. Don't really warm the earth, but they do heat it via greenhouse gases. Carbon dioxide. It's the true problem here, and what happened with the Siberian Traps. Basically, during that event, the planet-wide volcanic disaster helped an extinction level event because of CO2 gases. It released roughly 10,000 gigatons of CO2, and its most active was pumping 10 gigatons of CO2 per year. But our hell world of Land Before Time is far worse than that. A literal 2 times as intense, meaning we get 20 gigatons of CO2 every year, which is half our own by human hands. And if you remember, this is natural output and has no human intervention to help out. Plus, the time period is already a high CO2 world, double our own levels, so adding even more for thousands or millions of years would be detrimental for the entire environment. Now, where this gets even more complicated is the volcanoes also releasing sulfur dioxide, which forms in a sunlight-blocking aerosis in the upper atmosphere. That is very bad. We've seen it before in the eruption of Mount Pinatubo in 1991, where it cooled the entire planet by about 0.6 Celsius or 33 Fahrenheit for a whole 2 years. Now, with the amount of horrible massive volcanoes we have in this world, we could be seeing sulfur pollution that would cool the planet actually down because it blocks the sun by a whole 45 to 60 degrees Fahrenheit. And this is really bad because now we have 2 competing forces in our climate fighting for thousands or millions of years, creating a violent, unstable world. All of this would make the planet's skies permanently dark and orange, which they are in the movie, make constant acid rain, and kill so many ecosystems because very few things can survive this hell. But this isn't the end. No, we still need to cover the actual simulation of this world, and after betting all of these problems and exploring a few new ones in more detail, we can see the total collapse of this ecosystem in under a year. Let me explain. In this simulation where I combine our problems together and run things month by month, I will try to contain the Great Valley ecosystem because outside of it, everything is kinda already dead. But inside it, for some reason it's not, and that's what I want to braid. But that doesn't mean I won't mention it outside it, and most importantly, these effects are very much applied to the whole world shown in the movie. Using basic measurements of numbers, I'll say the square miles of the Great Valley is between 50 to 100, which is comparable to say a small national park valley, or even honed in a single number being 80 square miles. Next off, we should estimate our plant production or food supply, as that is probably the most important thing here. Real lush paradise-like ecosystems produce 500 to 1,500 grams of plant biomass per square meter each year, so I'll be generous and give us an upper end of 1,200 grams. Now, taking the size of the valley and our plant growth by said size, we can come down to a huge 248,400,000 kilograms of plants per year, which is making this paradise seem possible. Now, moving on to estimating the population, we only have herbivore dinosaurs here, and I can say it's probably not some huge population. I'm gonna save us all some time by skipping over how many dinosaurs I calculated and what they need and just add together our total, which is a very generous 1,000 animals of varying sizes and plant requirements, coming out to 24,500 kilograms of plant consumption per day. That is only 8.9 million a year, and while the valley is growing 248 million in a year, so things are looking sustainable. Now, yes, maybe this is because I'm being unnaturally generous as I know what's coming, but still, what could make this not work? Well, herbivores can only eat 10 to 20% of plant growth in a year. Why? Well, plants need leaves to photosynthesize, roots to store energy, seeds to reproduce, and backups for the many disasters and diseases that will exist. If you eat too much, the vegetation would begin to collapse. Our maximum safe food supply currently is under 49 million kilograms, which is safe currently, but will run into problems, and again, is me being generous to a world that inhabits demonic T-Rexes and hell volcanoes. In real ecosystems, most plant growth actually never reaches large herbivores because of ecosystem laws. Think about it, whether it's rot, which usually takes out 30% of plant growth, then insects and fungi, seasonal droughts and just die-offs, and just some plants animals can't reach, that altogether hit a 60% total. That leaves only 10% of all plant growth in this valley accessible and edible, meaning we only have 24 million kilograms left, ignoring the previous rule of 10 to 20%, or under 5 million, which is just not gonna work when we need 8.9. I'm actually gonna use the first number because we are under the idea of this all happening in a short time period in our simulation, meaning I don't think the long-term effects really matter. Now, our final killer is the overgrazing problem due to too many herbivores, and how plant growth itself will just kinda stop. See, we see this in the African savannas or certain populations in our world. If you have too much heavy grazing in just a year, you can see a 30 to 60% drop. If we go for a higher number of 40%, we still barely meet our requirement with 9 million kilograms per year, and with a bigger problem that will just keep happening as everything in a good year or two will fall apart until there is nothing left. And that is my analysis of the Land Before Time. How the ecosystem is one that in climate makes no sense, nor its weird, not natural paradise, and how if we run our simulation of science, we will see things fall apart so quickly, till this world is truly hell. If you would like more videos like this, click on this playlist right here for my overanalyzing science videos on nostalgic shows, or this video which YouTube thinks you'll like. Either way, bye!